This is section 2.6, dividing real numbers. The first thing before you start multiplying and dividing is you have to understand that the reciprocal of any non-zero number, a, is 1 divided by a. I usually call that the inverse, but they call it the reciprocal in your book most of the times. When you multiply a by 1 over a, you always get the answer of 1. Therefore, what they call 1 divided by a is the multiplicative inverse of a, or I just shorten it and call it the inverse. Right? Whenever I say the inverse, I'm talking about the multiplicative inverse. 0 doesn't have a multiplicative inverse because you can't divide by 0, so 1 divided by 0 is undefined. But every other number, there should be a 1 divided by that number that's a multiplicative inverse, and when you multiply it by the original number, you get 1. So knowing that, we're going to take a look at the inverse property of multiplication. The inverse property says a times 1 divided by a equals 1. That means the product of any non-zero number a and its multiplicative inverse is always 1. Now the key here is that this multiplication always results in a positive 1. It cannot be negative 1, so you have to watch your signs to set up your inverse correctly so that you're either multiplying two positives or two negatives. So the multiplicative inverse of 5 is 1 over 5, or 1/5, because when you multiply 5 by 1/5, you get 1. But the multiplicative inverse of negative 1/5 is negative 5, because when you multiply those two together, you would get positive 1. The division rule says to divide any number a by a non-zero number b, you multiply a by the multiplicative inverse of b. So a divided by b is actually a times 1 over b. But in this case, b cannot equal 0 because you cannot divide by 0. It's undefined. 5 divided by 2 equals 5 times 1/2, because 1/2 is the multiplicative inverse of 2. Now the sign of the quotient is your answer, right? The sign of a quotient, the quotient of two numbers with the same sign is always positive, and the quotient of two numbers with different signs is negative. And the quotient of 0 and any non-zero number is 0. Okay? That means 0 divided by a number, you always get 0. So the examples of the sign of the quotient rule are below. You see 6 divided by 3, that's 2. It must be positive because both 6 and 3 are positive. In the second example, 6 divided by negative 3, that must be negative 2 because they have different signs. The answer must be negative. And lastly, 0 divided by 8 is 0, because 0 divided by any number is 0. Again, I have to stress that you cannot divide by 0. That is undefined. There is no answer for a problem like that. Now we're going to apply the division rule to fractions. This is really important, and it makes dividing by fractions a lot easier to understand. Since division is multiplication by the inverse, then the fraction problems actually become simple. When you take 6 and divide it by 1/4, it's actually 6 times the multiplicative inverse of 1/4. And the multiplicative inverse of 1/4 is 4, so that actually becomes 6 times 4, or 24. Try the next one. If you look at negative 20 divided by negative 5/3, it's actually negative 20 times the multiplicative inverse of negative 5/3, which is negative 3/5. So we're going to multiply these out, and the result is positive. Since you're dividing two negatives, you get a positive result, which is 60 divided by 5. And 60 divided by 5 can be reduced to 12. We're going to find the mean now. Remember that the mean is the average. So to calculate it, you have to add all your terms in your data set, and then you divide by the number of terms in your data set. So we're going to look at the table below, and we're going to find the mean daily temperature for this location. You can see we have data for 5 different days, and the temperatures are below the number of the day. Since you have the data for 5 days, To find the mean, you're going to add the 5 temperatures and divide by 5, the number of days data that you have. So the mean in this case would be negative 21 plus negative 29 plus negative 39 plus negative 39 plus negative 22, all divided by 5. That becomes negative 150 divided by 5, or negative 30. Whenever you're finding the mean, you add all the numbers in the data set and divide by the number of numbers that you have. We're going to look at simplifying expression. This gets a little tricky. When you have 2 or more terms in the numerator, you can divide a couple of different ways. I'm going to show you 2 ways here. The first one is to rewrite them as a multiplication problem and then distribute. So in the first example, when we have 36x minus 24 divided by 6, that actually is 36x minus 24 all multiplied by 1/6, right? Multiplying by the inverse. So if we set it up that way, it looks right away like distributive property. And you're familiar with that. So here we're going to distribute now the 1/6 to each term. I think you'll feel more comfortable doing this than dividing by 6 straight off, because multiplication is always more comfortable than division. So on the next line, you can see that I'm multiplying now the 36x times the 1/6, and then the 24 times the 1/6. Don't forget, you cannot lose this sign, right? This negative sign has to come down. The subtraction has to come down to the next row, or you're going to be really far off. So when you multiply 36x times 1/6, you get 6x. And when you multiply 24 by 1/6, you get 4. So this problem actually becomes 6x minus 4. Now in the second option, it's a shortcut. And maybe some of you will see this a little bit easier than the first option. So you choose which one you're more comfortable with. But in the second option, when you have 2 or more terms in the numerator and a number in the denominator, you're actually dividing each thing in the numerator by that number in the denominator. So you can split it into a whole bunch of separate fractions. If there are 3 terms in the numerator, you would have 3 fractions. If there are 5 terms in the numerator, you would have 5 fractions. And you could break it up that way. This is actually the way I like to do it. So in this case, we have a 36x and a minus 24 in the numerator, and the whole thing's divided by 6. So we're going to divide the first term, the 36x, by 6, and the second term, the 24, by 6. When you do that, you get 6x minus 4. It's exactly the same result as the first method. It just might be a method that you find easier. I find it simpler to do that way. So you should practice some of these on your own to see if you can do them.